Hello, it's Professor Johnson. In this brief video, I would like to show you how to use SPSS to calculate a one-sample t, to generate the associated p-value, and to make a decision, and then what data to use to write up your analysis. It is the case that I'm assuming here that you already know when to use a one-sample t, the assumptions that we're making with a one-sample t, how to make a non-directional versus a directional, that is two-tailed versus one-tailed decision, and how to set alpha. If you don't know these things, it's worth reading up on a one-sample t before proceeding through thinking how to use SPSS to generate one. Here we're told that the nerve is a test of nervousness measured on a scale that is assumed to be interval and has a population mean of 100. Lower scores on the nerve indicate you're less nervous, higher scores indicate that you're more nervous. 10 participants, so N of 10, are randomly and independently selected and given 2 cups of bold coffee. 15 minutes after coffee consumption, the participants complete the nerve, and now we see the actual scores from these 10 participants. So what we have here is a population with a mean of 100 with no known population standard deviation, a sample of 10, and the question presumably is whether coffee changes nervousness. We can ask that non-directionally by saying coffee could potentially increase or decrease nervousness, or we could ask it directionally. But in this case, let's just do a non-directional test with an alpha of 0.05. To run these data through SPSS, we'll need to open up a data file and go over to variable view and create a name for our dependent variable. Here I'm just going to call it nerve. I'm going to move over. I'm going to set my decimals to 0 since my dependent measure here seems to be measured in whole units. I'm going to give this a slightly longer label. I don't need value labels. I don't have any missing data. I'm going to set the measure to scale, meaning I have interval or ratio data here. Then I will go over to data view and enter the scores on the nerve. And again, every row is a different participant. I have a 102, a 101, a 107, 101, 102, 99, 101, 104, 103, 100. And I'm going to go backwards and double check I entered the numbers correctly. Garbage in, garbage out when it comes to data entry. 100, 103, 104, 101, 99, 102, 101, 107, 101, 102. The more important your data, the more you want to be sure they were entered correctly. Anything that's going to be used to actually make decisions that are important to you, it's always worth having another person check your data as well. We're going to go to Analyze, Compare Means, and do a one-sample t-test. The easy part of the one-sample t is picking which variable you want to do the t on and moving it over to the test variables box. The hard part for many students is remembering to set this test value. This is what you're comparing your sample mean to. It's mu under the null hypothesis. So it is what is the population mean under the null. And in our case, that is 100. Okay? If we had left this at 0, which is the default, you know that's going to be statistically significant than 0 because these scores are all around 102 or so. But in this case, the null is that these samples, or this particular sample, was drawn from a population with a mean of 100, and we're going to test that null. We click OK, and faster than you can do with your calculator, SPSS gives us this beautiful bit of output. We had an N of 10. The mean of our sample is 102. The mean under the null, test value, is 100. The standard deviation of our sample is 2.26. Standard error of the mean is 0.715. Now, depending on how your instructor talks about standard deviations, standard errors of the mean, these are actually estimated standard deviation and estimated standard error of the mean. SPSS computes this value by taking the sum of squares of the sample, dividing by n-1 and taking the square root of that. This is our best guess of the population standard deviation given the sum of squares of the sample. We then divide this number by the square root of n to get our best guess of the standard error of the mean given our sample information. So this is an estimated standard error of the mean. This t is simply 102 minus 100 divided by the standard error of the mean. So we have a t with 9 degrees of freedom that's equal to 2.80 with a p that's equal to 0.021. In other words, the probability of obtaining a t this far away from 0 or further away from 0 in either direction is 0.021. This is less than our alpha of 0.05, so we would reject the null hypothesis. We have everything here that we need to write up our information on our one-sample t. N of 10, mean of 102, standard deviation of the sample, t with 9 degrees of freedom equals 2.80, comma, p equals 0.021. We're good to go. The only difference for those of you who are taking a class with me with SPSS's output and how your book likes to think about things is this is the confidence interval of the difference between the true population mean that the sample came from and the actual population mean under the null. And so if this includes 0, you're not going to reject the null. And if it doesn't include 0, you will reject the null. But this is a confidence interval of the difference. Okay, that's how to use SPSS to generate a one-sample t. Thanks for watching.